All right, math friends, it is time to look at some applications with trig ratios. So if you guys could please complete the warm-up, and then when you are finished, please resume the video, and you can check your answers with my key. All right, you should have finished the warm-up. I have my solutions here. So what you guys can see, the first thing I did was find that missing side length by doing the Pythagorean theorem. You should have gotten a value of 12. After doing that, I found my sine ratio and reduced it. You should always reduce. And then to find my cosecant, I flipped it. Cosine, I did that adjacent side over my hypotenuse and then reduced, flipped it for the secant. Tangent, I did the same thing and then reduced, flipped it for the cotangent. And then for tangent B, note the other angle. So now your opposite and adjacent side flipped. So when you're looking at angle B, the side that's now opposite is the side with the measurement of 9, and the adjacent side is now the measurement with the 12. So I reduced that, and then I flipped it for the cotangent. Now, when asked to find the measure of A, you had 3 different options that you could use. You could take the sine inverse of 4/5, you could take the cosine inverse of 3/5, you could take the tangent inverse of 4/3. Any of these 3 ratios that you set up, if you do the inverse of them, you will find that you get that same exact angle. So you could try it out. If you did sine inverse of 4/5, now try the cosine inverse, and you should check to see that you get all the same answer no matter which way you type that in. So let's now look at applications. This is so important for the ACT, SAT. A lot of us remember those tree shadow problems and angles of elevation and depression. We're going to look at, I think, 4 different examples and talk about how you set up these diagrams and find missing measurements, like what we did yesterday on the, well, not yesterday, whatever day, the last time you viewed the video for the notes, the first day of notes in this unit. So the first question is about water skiing and how a ramp rises at an angle of 15.1 degrees and is 19 feet long. What is the height above the water that a skier leaves the ramp? Now, one thing you're going to learn about me is I am not a good artist, but I always try to draw out the situation because that mentally helps me to figure out what I actually need to solve. So if I'm trying a water skiing ramp, first of all, let's get some water. And then we're going to have this ramp on the top of the water. And what we're going to see is that because it's a ramp, I don't know if you guys have ever been to like Wisconsin where they have those like shows, those water ski shows, air and water shows, or not air and water, I don't know, but they do the shows where they have people like do really cool tricks off of ramps. So if we're drawing a ramp on top of the water, just think about how we're going to have this ramp rising above the water. And we are told in our description here that it's rising at an angle of 15.1 degrees. So that's talking about this angle right here. And obviously, these are right triangle problems, so we do need to have a right angle in there somewhere. Now, it's saying that the ramp itself is 19 feet long. So just think about what of these 3 measurements of the sides of the triangle represent the actual length of the ramp. Well, that's this part right here. That's where the skier, if you want to even draw a skier, oh gosh. Those are the skis. Okay, I should have stopped while I was ahead. But there he is. He's missing something. I don't know, the string, right? I don't know. And then there's a boat in the distance. This is horrible. So we want to find the height above the water that the skier leaves the ramp. Well, that's this measurement X. So if you guys want, pause the video, see if you can find X using the your knowledge of what we did last time. But when you're ready to check your work, you can resume the video. So to solve this one, you should have thought across from angle 15.1 is your opposite side, and they gave us the hypotenuse side. So that means that we're going to use the sine ratio because we have the opposite and the hypotenuse side. So you should have said that the sine of 15.1 degrees is equal to x over 19, and then to solve for x, just multiply both sides by 19. So in our calculators, we should be doing, and I actually need to check my mode because every time my calculator resets, it goes back. We want the 19 times the sine of 15.1. Oopsies. And we are getting that x is approximately 4 point, how does it say it around? round to the nearest 10th, 4.9 feet. Okay. It makes sense that that's a smaller measurement because think about the angle. If you think about the first day of notes, that angle was a lot bigger that we were finding, it might have been 48 degree, 48, 50, whatever. So you're gonna have a bigger measurement. But because that's a smaller angle, we're seeing that smaller side across from it. All right, so let's look at the next example. If you want, you can try to pause the video and see if you can set it up on your own and then try to solve it as well. But I will definitely work through it right now. So this problem says a support cable stretches from the ground to the top of a 208-foot radio tower. If the cable measures 250 feet, what angle does it make with the ground? Every time I think of these problems, support cables, I think of like gymnastics. If you guys ever see like a lot of things are tethered in, like there's support ropes that keep it in place so no one gets hurt. So if I have a radio tower, get ready, here it goes. Here's my radio tower. I don't know, and maybe we'll put little antennas at the top. I don't know, this is getting bad. But we have a cable that is to the top of this radio tower. So we're gonna have this cable right here, kind of supporting. I know this is getting worse and worse. Someone's gonna look at your screen and be like, is that a bug? But we have that the support cable stretches from the ground to the top of the 208-foot radio tower. That means that this measurement right here is 208 feet because that's the height of the radio tower. And the cable measures 250 feet. Remember that the cable, even think about like gymnastics equipment, that cable is going to be this piece right here. It's not on the ground. The cable's not running on the ground. It's supporting it from the top. So we are asked in this case to find the angle it makes with the ground. That's x. And I'm going to put x degrees just so we know we're finding an angle here. So again, if you want to pause the video, if you haven't already, try to set it up. But for this one, what we're going to do is we are going to think what sides we have relative to x. This over here is my opposite side. This over here is my hypotenuse. So again, a sine problem where we're going to do the sine of x equals 208 over 250. And remember, whenever you want to find an angle, you can even say x degrees to remind yourself you're finding an angle. We are going to use the inverse function for that ratio. So in our calculators, we do sine inverse of 208 divided by 250. And we are getting approximately 56.3 degrees. And again, that makes sense. We have a bigger measurement there for the side across, so it should be a larger angle. So that is the first two types of problems. What I am going to show you in the second part of the notes for today is this idea of angles of elevation and depression. So they give you a scenario where they say Steve, I don't know if you know Mrs. Kane, but her name is Kristen and her husband name is Steve, so that's funny. He is on the sky deck of the Willis Tower, and Kristen is on the observation deck of the John Hancock Center. The two are looking through telescopes at each other. Aw, so romantic. The horizontal lines at the top and bottom of the diagram create two different types of angles that you guys need to know. Whenever we talk about an angle of depression, I know that sounds sad, think of a frown face, you need to have the horizontal line, and what you need to do is you are going to create an angle with that horizontal. You're always going to hear me say with the horizontal. So you need that horizontal line. It's the angle measured right here. We call that the angle of depression. Now, when you're talking about angles of elevation, they are also made with the horizontal line, but instead of going down like depression, think sad, angles of elevation go up like smiley faces. So if you guys note, and it says right here on the side, why are the angle of elevation and angle of depression the same? See what you remember from last year? If you guys remember, these two horizontal lines make up parallel lines. And this line in the middle that's going diagonal right here is the transversal. So that means that our angle of depression is actually going to be equivalent to our angle of elevation because they're alternate interior angles. So kind of a cool thing if you remember that from geometry. Now, let's see how these problems are going to work. They're pretty much the same process as the problems you've already seen. The big difference, though, is that they're going to say the words angle of elevation and depression, and you need to make sure you set it up correctly. So for question 3, it says, from a point on the ground 12 feet from the base, that's a key word here, base of a flagpole, the angle of elevation to the top of the pole measures 53 degrees. How tall is the flagpole? So we are going to put a point on the ground and we are going to connect it to the base of some flagpole. And they are telling us that is 12 feet. Notice it says base, so I need to put that at the bottom. Now it's saying the angle of elevation to the top of the pole. So let's create this pole, and I think they said this is a flagpole, so we can kind of draw on a flag there. To the top of this flagpole is 53 degrees. And we want to find out how tall is the flagpole. So if you want to pause the video, feel free to do so. But let's see how we are going to set this up. Across from 53 is the adjacent, the opposite, silly. And the adjacent side is the 12. So I see opposite adjacent, I'm thinking tangent. So I'm going to say that the tangent of 53 degrees equals x over 12. Now to solve for x, I'm going to multiply by 12. And so in my calculator, I do 12 times the tangent of 53, and I should get that x is approximately 15.9 feet. Notice in the directions it says include units. That's very important that we have our units there, but that measurement would be 15.9 feet, which makes sense because it is a side length of a triangle. And if you know a little bit about geometry, you could find this angle right up here, and you would notice that it's smaller than the 53 degrees because, 90 minus 53 is going to give you that measurement. And you'll see that because the 53 is larger than the other angle, the side across will be slightly larger as a result. So, final question of the notes for today. A pilot is flying at an altitude of 4.6 miles. So keep in mind that's the height above the ground. It says along the ground, his plane is still 16 miles from the airport. What is the angle of depression from the plane to the airport? So let's first of all get our plane. I'm really bad at planes. I understand my planes look like bugs or fish or whatever, but this is going to do, okay? We have an altitude. So this is a height. I don't even want to hear your comments right now about this. Of 4.6 miles above the ground. Now it says along the ground, his plane is still 16 miles from the airport. So along the ground, that's kind of like that word base up on the top. Along the ground is a very important part of this. Now it says, what is the angle of depression from the plane to the airport? So here is my airport. I don't know, it's just a building. I don't know. A lot of people connect this and then they think that this angle right here is the angle of depression. It's not, my friends. This is not an angle made with a horizontal line. If you were to draw the horizontal line here, remember with Steve, how we had that, and Kristen, we had the horizontal line. The angle of depression that they actually want you to find is not that angle, which is a very common mistake. It's this angle. That is your angle of depression from the plane to the airport. Now, you have a couple options. Option 1 is you can just relabel over here that this is 4.6 and that this is 16 and that you want to find this angle x. But if you remember what I just said about alternate interior angles, second option is that this angle of depression is going to be the same thing as this angle of elevation. So you can also set up your triangle using that angle of elevation from the airport to the plane. So with that being said, let's set up this problem. Again, freeze the screen if you want to do it on your own and then check how you did. Either way you look at it, we have the opposite side and the adjacent side for x. So we are going to say that the tangent of x degrees equals the opposite side over the adjacent side. Now to find x, we are going to do the tangent inverse of that ratio. So tangent inverse of 4.6 divided by 16, you are getting that measurement is approximately 16 degrees. Now, let's just say you accidentally did find this angle. Keep in mind that if you subtract that from 90, it would give you the angle that we actually wanted to find. So if you did accidentally find the wrong angle, then just subtract from 90 and you should have the correct angle of 16 degrees.